Hi, my name is David Rice, and today I would like to walk you through a simple demo using IBM Open Data Analytics for ZOS. The purpose of this demo is to showcase how easily data can be analyzed and placed on ZOS, or as some of you may know it, the mainframe environment. Many of our large enterprise customers run their core business operations on ZOS, and these processes generate a huge amount of high-value data. In this demo, we'll be using a sample dataset, in this case, a publicly available procurement dataset associated with a government entity. So let's start up the Payable Transactions Notebook. We are running this Jupyter Notebook server on ZOS, so all the work will be done on the mainframe. If you notice, this notebook is using some of the more industry-prevalent Python packages, such as Pandas, NumPy, SciPy, Matplotlib, and Seaborn. We are also using a special library specific to IBM Open Data Analytics on ZOS called DSDBC. DSDBC accesses data via the Optimized Data Virtualization layer, a component of the IBM Open Data Analytics for ZOS. This layer reads various data types like DB2, VSAM, IMS, physical sequential, as well as many others, and makes a virtual table of its contents. It then exposes it to DSDBC as if it were a database table. So, we will load a few physical sequential files using an SQL statement. Now that the data is loaded, we will take a quick glance at it. If you notice, it loaded into a Pandas data frame and included the correct types. Now that we have the data loaded, let's look at some basics, like the total expenses, the total revenue, and the net total of each year in our dataset. Let's go a step further and graph these out. The expenses seem okay, but for some reason 2016's revenue seems off. It has an inconsistently small amount of data for that period. This would imply that there may be some data that has been omitted. The net shows the same type of information. Let's go a step further and learn some information about the vendors we are dealing with. We will first load another physical sequential file into a data frame. Then we will merge that into the expense and revenue data frames that we created earlier. If you notice, this data has some strangely similar names, like several Stanhopes and O'Briens. Let's keep going. Let's do some simple work to calculate the grand total per vendor, as well as their average per year. We will go a step further and look at the top 20% of vendors. There's a loose rule when dealing with procurement data that says 20% of vendors should make up approximately 80% of the transactions. So, after a few quick calculations, let's see how many transactions belong to the top 20% of vendors. Notice, we didn't get anywhere near 80%. We only got 33%. So something seems very wrong with this data. It could have had something to do with the vendor name issues I pointed out earlier, or it could be a bigger problem with the data itself. Let's pretend for a moment that the data we are reading in does not have any issues, and look at the top 5 vendors for both expenses and revenue. If you notice, the warrant register seems to be the #1 expense for this government entity. Let's look at it some more. For some reason, the warrant register, despite it being the thing that cost this government entity the most overall, has no expenses in either 2015 or 2016. This would imply that there is no crime in either 2015 or 2016. Seems highly unlikely. Similarly, let's look at the revenue. If you notice, this data would imply that the Department of Alcohol and Beverage, as well as the State Lotto, make more revenue than the Department of Taxation. For some reason, they aren't showing any revenue for 2016. Also, despite being pretty consistently increasing revenue for the Department of Alcohol and Beverage and the State Lotto, the Department of Taxation is all over the map, which again makes this seem like something is wrong with this data. The point is, with minimal effort, I was able to scan through a pretty large set of data and figure out some dramatic inconsistencies quickly and visually using the help of open industry prevalent analytic frameworks looking at live, real business data. The idea is, instead of wasting your time doing larger calculations on incorrect data, you can analyze the data ahead of time to see if the data is any good, or if you need to investigate where problems may exist with it. In addition to consistency assessments and mitigation, you can use these same frameworks to efficiently and quickly aggregate and distill this high-value data for downstream analytic processing and integration across your environment. Again, my name is David Rice, and thank you for watching.